right, how goes it? How's PA2? Pretty much done? All right, so I'll run through the ODP that you just finished in a minute. But any questions up front? Yeah.
I was curious about if we could go over a little bit on exclude void functions. I've been having an issue with one line where everything looks right, but it's like, hey, this is underlined.
Okay. Let's talk about void because it's potentially a little weird. So let's say you have a function called func, and we want to pass it an integer and a character, right? So I don't know, this is integer I and this is character C maybe. And we say integer func. Okay, so functions have two things. There's something that goes in, there's something that comes out, right? Okay, so this function, there's two things going in, an integer and a character. There's one thing coming out which is going to be an integer. So to use this function, I would say something like, you know, blah blah x equals function, I don't know, 12 comma letter A, right? And somewhere in my function I need to have a return statement that says return something. Okay, so I call the function. This code starts to execute. I is set equal to 12, C is set equal to the letter A. At some point there's got to be a return statement that executes. If that returns, say, the number 7, then when I come back here, this function is treated as if it's equal to the value 7, and this says set x equal to 7. Okay, so send things into a function, return something from the function, and then you can use that return value. Okay, it's legal in C to just do this. To say, I don't care what the return value is, I'm not going to do anything with it, and I'm just going to type in the name of the function, tell it what I'm passing to it, get those things back. You know, it returns some value and I just ignore it. But I still need to return some value from here. If I just say return or I don't say anything, it's going to complain. You're supposed to be returning an integer and you didn't. Okay, if in fact I don't plan to do this at all, if function is supposed to take some arguments but not return anything, right, I can tell it I'm not going to return a value by saying void function. And then when I want to return, I just say return without specifying a value. So it's not really a type of variable, it's a little trick that we use to say there is no return value, right? And so we're not saying it returns a void, we're saying func doesn't return a value. And we're going to call it just like this. And that might be, you know, your print stick routine. Maybe you call print stick, you pass it the number of sticks, it's just supposed to print out the sticks and then return. You're not trying to get any information back from that function. That might be a function you declare void, right? Or you just declare it an integer and you just say return 0 and you don't do anything with the 0. Either of those will work. You can also put void inside here, but you can also just leave arguments off. I don't think I've ever knowingly used void in a C program in my life, other than when I was explaining it as an example. I always just use ints and I just return 0 or whatever. But this is a cleaner way to do it. Does that make sense?
Yeah.
Okay, cool. Other questions? Yeah.
So I have a question about VI.
Mm-hmm.
So I put when first I read all my things in main function.
Okay.
And then I figured out there's some part is I always read the same part. That part is same. So I want to copy this part and then to another file which I want to be that become a function and paste in that file to become
Okay.
know how to do that?
So you want to take some code from your main and put it into a separate file?
Yes.
Okay. There's a few ways to do that.
Okay, can you also show that how to copy that in the same file too? Like copy the
Okay.
file.
All right, so for example, here's some code that prints out our pile of sticks, assuming that num_sticks was the number of sticks in our pile, and there's some code before it and some code after it. Okay, so there's a few things you can do. One is just plain old copy and paste, right? Using Windows or Mac or whatever. For example, I could highlight all of this text, and then I can come down here and I can go into insert mode and I can just paste. Okay, that's the least specific way to do it. That's just using copy and paste from Windows or whatever your OS is. If you want to do this inside VI, you can do a little counting. So I've got 1, 2, 3, 4, 5 lines in here. So I can say 5 and a shift Y, and that pulls 5 lines into what's called the yank buffer. It's the clipboard basically. And then if I just hit the letter P, it'll paste it wherever my cursor is. And then if I want to go into a separate file, right, I could vi printstick.c. I can go into insert mode, sorry, don't go into insert mode, go into your new file and just do your P in there and it'll paste it in there. And then you can add the function header and stuff like that. But regular copy and paste, however you normally do that on whatever operating system you have, will always work.
So all these are not under the insert mode.
If you're going to do copy and paste, you need to be into insert mode when you paste, because you're really just pretending that you're typing all this in, but you're typing it from the clipboard. The P for putting, right, 5 yank, the P is not in insert mode. That's in command mode. More questions?
Should I do one?
Yeah.
I forgot how to include like other. So he was mentioning a function in another file. I forgot how to include that in the main.
Okay, good. So let's actually write this. So let's make a function over here. Okay, so here's a function called printsticks. It takes an integer called num_sticks and it loops, prints out the pipes, and then prints out the value of num_sticks. And I'm including stdio because I have a printf in here. If you don't need stdio and you include it, it usually doesn't do any harm. Okay, if you don't need it, it's better not to put it in there because it's more stuff to compile. But if you're doing printfs, if you're doing scanf, if you're doing fgets where you're saying stdin, you need standard io.h. So I'm going to have that in here. So So let's go into my main program, and I'm not going to do all of this stuff in here. I'm just going to say print sticks, 10. Okay, so one thing, this may compile. It may complain. Okay, good, it complained. So it's giving me a warning, implicit declaration of print sticks. I'm calling a function that it doesn't know anything about. It'll assume it's going to return an integer and so on, but this is why we do what's called prototyping. So we put a statement in the beginning before main to say, what is print sticks? Okay, print sticks is a function that does not return anything and takes a single int. Alright, so that's not writing the function print sticks, it's prototyping it. It's saying, what does print sticks look like? And the difference is there's a semicolon at the end of that. Whereas if we actually write a function, the closing parenthesis is followed by a curly bracket, right, where we actually write the body of the function. So this is a function prototype. That's basically what I just described. It's telling the compiler the name of the function, the type of arguments, and the type of return without describing the actual code, right? So it's like a system diagram in 120 or 250. What's the block, what goes in, what comes out, right? But none of the details about how that actually happens. So we just call that a function prototype. It's just a term. That's how I use it, at least. Alright, so when you want to call the function, you just type the name of the function. If it expects arguments, you put those arguments in the parentheses, otherwise just parentheses with nothing in between. And then the function itself, right, is written the same way that you would write it in your main program if it was in one file. So we've got two C files now, main.c and printsticks.c. Okay, easiest way to compile them, gcc-o main, and then just list your .c files. And that should give you an executable. So as long as you prototype, so that's the other thing prototyping is doing, it's letting it know about functions that aren't defined in the current file. So long as you have those declared in main and you've got a file that has all your functions in it, right, you can just name them all in that big GCC command.
Isn't there a way to include printsticks.c in main.c, like not the actual, like not actually write it in there, but like let's say you're that include. Isn't there a way to include other like main file, you know, like personal files? Like so like instead of include standard IO, it would be like include
printsticks.c. Yeah. Okay, so you can do that and it'll work, but don't. Okay, so if we do this, what this does is it takes the contents of that file, printsticks.c, and it loads that all right there in place of the include statement. Okay, that will probably be perfectly fine in this case, except that printsticks.c also includes stdio.h. So it may get confused about that. It'll handle it though. But when we start talking about makefiles and about building projects that have, 10 or 15 separate pieces to them, if we do this, we're going to defeat all of the advantages that makefiles give us. Because every time we compile main, it's going to compile all the code inside printsticks. Okay, because it's actually pulling that in as part of the main program. So if we do it like this, and we keep printsticks in printsticks.c, here's what we can do. I can say compile printsticks.c. I can say compile main.c, and don't worry about this if it doesn't make sense, because we'll get a lot of chance to play with this later. I can say let's build an output file called main by putting these two already compiled files together, main.o and printsticks.o. Those are the compiled versions. And now if I want to change main, I change main.c, I compile main.c to make a new main.o, and I redo this. I don't have to recompile printsticks. Right? If I do it like this, I only have to compile the things that I change. So if you're building the Linux kernel, which has, I don't know, 10 or 50,000 different files associated with it, and you change one file, you don't want to compile the other 49,000 plus. Right? So that's where makefiles will take us. All right. Other questions? These are all great questions, by the way. All right, so let's look at ODP 451 just for completeness. So there's an example of the input function we were after. Doesn't return anything, so it says void input. Takes a pointer to a character array. Calls fgets to read from standard in. And I've got arg as the first argument because that's where I want to store the stuff that the person has typed in. And then I'm going to remove the last character from. Some people did fgets into a temporary array and then copied that into arg. That works great too. Okay. But ultimately, whatever the user types in and fgets reads needs to end up in this character array called arg. 120 is the length I told you could assume, and standard in is always going to be standard in if we're trying to read from the keyboard standard in. And then find the length of that, right? And then subtract 1 from that and use that to index arg and set the character at that position to a null. And then just return, and there's no value that we return, which is why we made it void. So there's a lot of ways to write this, many of which won't work, and a few which will. But hopefully the reason that this works makes sense, right? Other than you stopped when you got here because it worked. Fgets is always 3 arguments: where you want to store the stuff, how many things you're allowed to read, and usually standard in for now. We'll change that third one later on when we talk about file I/O. All right, good. So somebody asked me in the afternoon, the second section yesterday, to flowchart PA2. Would that be helpful in here? To kind of see like the overall view of what's going on. And I'm thinking I'm gonna do a mix of flowcharts and structure charts, maybe for PA3. All right, well let's look at PA2. So we know the basic goal, right? So this is PA2. Probably first thing you want to do is know, did the user tell me how many sticks to play with already? Did they say stick space 25? Did they say stick space haha, right? So what's the one variable that we want to check up front to know whether or not the person specified something on the command line other than just the name of the program? argc, right? argc tells us the count of how many arguments there were. That's the way to know, did they say stick or did they say stick something? Okay, so, and there's a few possibilities. argc could be 1, which means it was just stick. Could be 2, which means stick something. Could be 3, which means stick something something else. Okay, 3 is an error. They can't say stick something something else, even if they're all integers. So one thing you can do is ask, is argc bigger than 2? And if it is, tell them there's an error and return. Program's done. Okay, the next possibility is argc is equal to 2. And if it does, they said stick something. Okay, how do we find that something? Where is that something available? argv, where in argv? argv bracket 1. Okay, if they said stick something, this is argv bracket 0, this is in argv bracket 1. So let's check argv bracket 1. Is it an integer? And it's got to be greater than or equal to 10. So is argv bracket 1 an integer greater than or equal to 10? You got to write a bunch of C code to do that, scanfs and all sorts of other stuff. But is this thing a valid integer within range? And if it's not, what do we do? Error and return. Okay, if argc is equal to 2 and argv bracket 1 is a valid integer, then let's do something like numsticks equals whatever that integer was. So numsticks is going to be the variable I use in this flowchart to represent the number of sticks in the pile. Okay, it's the number of sticks we're playing with. So there's another possibility here. argc was not equal to 2. Well, if argc is not bigger than 2, and it's not equal to 2, what is argc equal to? It's got to be equal to 1. It can't be equal to 0 because it's always at least 1. So we know argc is 1. In other words, they just said stick, so we have to ask them how many sticks to play with. So let's do that. So how many sticks? And we're going to do an fgets and an scanf and so on and so forth. Read the number of sticks. Okay. Did they type something legal? If not, what do we do? Tell them there's an error and return. If they did type something legal, then we're going to set numsticks equals whatever that number was that they typed in that we decided is legal. So at this point in my program, what have I done? I've decided how many sticks we're going to play with. And we've stored that in a variable called numsticks. Okay, so we'll put a little continuation mark here. We'll go down to page 2. All right, we know how many sticks we're going to play with. User gets to go first. right? So ask user to pick sticks. Print f gets. Did they type in a legal number, an integer not followed by anything else that's equal to 1, 2, or 3? If not, go back up here. Ask them again, input a number. Once they input a legal number, subtract that from the number of sticks. Print the stick picture. So the vertical bars with the number of sticks in parentheses. And is the number of sticks less than or equal to 0? Because if there's only one stick left and the user picks 3 sticks, you're going to end up with -2 sticks. That's okay. Is the number of sticks less than or equal to 0? If it is, the user won. And we're done. Good. Alright, if there are still sticks left in the pile, let's go down to page 3. So page 2 is the user turn. Page 3, this is the CPU turn. Okay, so what's the algorithm for deciding how many sticks the computer is going to take? Say again? Okay, so take what mod for? What quantity? Total number of sticks. So num sticks modulo 4, let's call that take. Okay, so calculate the remainder when you divide num sticks by 4, store that remainder in take. Are we always going to take that many sticks? There's one special case, right? Because numsticks mod 4 can give us 4 possible values. 0, 1, 2, and 3. Well, we're not allowed to take 0 sticks, even though we'd like to. So we have a special case here. Is take equal to 0? If it is, what's the rules here? How many sticks should we take? Take 1, so set take equal to 1. Okay, so at this point, take is the number of sticks the computer is going to take. So subtract that from the pile num sticks. Print the stick pile. Print the stick picture. And see if the game is over. It'll never be negative in this case, but that's okay. Have we used up all the sticks? If yes, then we say CPU wins, and we're done. If not, what do we want to do? Yeah, if not, then it's the user's turn again, which means I'm going to go all the way back up to here. So go up to 2. Back up to the top. So that's PA2. And this, I would say, is probably a good level of detail for a flowchart. Ask user to pick sticks. Well, if you're doing that in C, it's a printf, it's an fgets. If you're doing it in Java, it's something different. If you're doing it on a pick processor, it's something very different, right? But whatever language we're doing this in, right, our goal at this point is to ask the user how many sticks they want to take and get an answer from them. Our goal here is to see if it's a legal number. We're going to use scanf. A different language would use something else. Java would say, to integer and so on. But it's sort of a logical block. And we're not worried about those details at the level of a flowchart like this. We're trying to understand, oh, I need some kind of big loop between here and here. And I need some kind of little loop right here where I'm asking the user. And that's going to be inside here. And then somewhere after that, I'm going to need an if statement that potentially returns from this function or continues, right? So it's sort of organizing the movement through your program from one section to another to help you structure your code when you actually turn this into code. And all of this stuff, right, it's pretty clear if you look at it like this, that all of this stuff up top is just introductory. It happens before we start this main while loop, which is the actual game playing. This is all just preamble, it's set up. And it's got some loops in PA1, right? We could keep asking them how many sticks. We don't have any loops in here, right? It's an if with another if inside. It's an if, and that's it. All right, does that help? Awesome. All right, other questions? All right, well, let's talk some more Linux. So you know about the date command. There's a sleep command. You can say sleep 5, and the system sleeps for 5 seconds while the command sleeps, and then it comes back. That can be useful sometimes. I'm going to ask you not to use those, though, in your shell script assignments that you submit to me. Because it's kind of nice when you're printing out information to print out the first line and then wait for 5 seconds, print out the second line, so it gives the user a chance to read, right? But it really slows me down when I'm grading 63 of these things. So I'm going to ask you not to use that in the versions that you submit, or put an option on there like -nice, and then if you run your script with a -nice after it, then you can do the nice civilized output rate. Another function is clear. Clear will clear the screen. That can be useful sometimes in the beginning of a game, clear the screen out, but I'm going to ask you not to do that also. Because usually I've got things ahead like a grading rubric or something that I'm using, and then I have to scroll back and so on. But it's a useful function for controlling the output. So sleep and clear are useful. There's a date function, there's also a time function, but time does something very different. Time is used to time a command. I don't think I've used this more than like 5 times in my life. But if you have a program that's doing something, you can say time space and then the name of the program. And it'll run the program, and when it finishes, it will tell you how long the program took. So I think I can do vi haha. So I can do some editing and, whatever. whatever. And when your command is done, it tells you, okay, you took 10.59 seconds of real time. And as far as how long the CPU was actually working, it looks like 6 milliseconds that it spent on my behalf and 3 milliseconds that it spent on behalf of the system. So this was mostly waiting for me to do stuff. Right, 9 milliseconds out of 11. And I don't imagine you're going to have a reason to use this, but sometimes it's fun just to have there. Or maybe if you play Rogue, you can like see how long it takes you to die. And it took me 4.86 seconds. So that would be a fun contest. See who can die quickest. It's a good speed typing thing. All right, we've talked about the history option, right? If you say history, you get a list of all your commands back to whenever your history got filled up. And you can recall commands by exclamation mark and the number of the command. So sometimes that's useful if you have something really long, or like I use it sometimes for you know, something obscure with a long file name. Let's see. So sort is a cool utility. So I say sort and I type in a bunch of lines and I hit Control D to signal end to file, right? And it gives me my output sorted alphabetically. And if you say sort file name, it'll sort the contents of a file. So I can sort main.c, and there's my C program alphabetized, which is not really a useful thing to do. But we'll have uses to use this for other things. All right, have we talked about word count, WC? So if I say WC and the name of a file, it tells me 3 pieces of information. How many lines are in the file? That's 8. How many words are in the file? That's 12. And how many characters are in the file, which is 100. So if I look at main.c, it's got 8 lines. I'm guessing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, maybe that one's 12. 12 words. A lot of empty space. And so WC can be useful. So I've alluded to this, and we'll play more with this another day, but we can use this pipe symbol, this vertical bar, to connect commands together. So WC, if I don't give it a file name, it just waits for me to type, and it'll give me a word count on whatever I typed in. So I typed in 3 lines, 10 words, 57 characters. LS shows me a list of my files. If I do the following, ls pipe wc, that'll say run the ls command, but instead of showing the output on the screen, send it to the input of the wc command. It connects these 2 commands together. The output of wc goes to the input of ls goes to the input of wc. And so when I do this, it tells me I've got 16 files. And it's a little weird because when I do ls and I pipe it, it actually displays it a little differently. It displays it like this, 1 file per line. Let's play with who instead. So who, it shows me everybody who's logged into the system. If I want to know how many people are logged into the system, I can say who, pipe that into word count, and it tells me there's 18 lines of output, so I know there's 18 people logged in.
So 18 means 18 people roughly.
Means 18 lines of output, and since I get 1 line per person, I interpret that to mean 18 people are logged in.
And 90 is 90 words.
90 is 90 words, which isn't meaningful to me, and 987 is total number of characters, which also isn't meaningful to me. Okay, let's just suppose I have this file called list. This is a list of all the commands that are being executed on the system right now. Forget about how I got this. This is all the stuff that's happening on the system. So I could word count that and see 198. There's 198 processes out there, 198 commands being executed. Suppose I want to know how many unique commands are being executed. Because, for example, we see bash a few times on here, we see sshd a few times on here, and so on. vi is on there twice so far, and there's a lot of the list before this. So there's a command called unique, uniq. And it's a little hard to tell what's happening here, but I typed hello, it said hello. I typed cool, it said cool. I typed hello, it said hello. I typed hello again, it didn't respond. The reason it didn't respond is because it already said hello. And since I said exactly the same thing I said before, it's not going to repeat itself. It's only going to say unique things each time that it says something. So I can say 1, 2, 3, and it'll say 1, 2, 3. I can say 4, 5, 6, it'll say 4, 5, 6. If I say 4, 5, 6 again, it doesn't repeat itself. So unique goes through its input, and if this line is different from the previous line, it'll show you the contents of this line. If it's the same as the previous line, it ignores it. So it's a way to take input and get unique entries out. So here's my file called list. If I say unique list, I get a slightly different file. Let me doctor this up. So I put the word awk in here 4 times in this file. If I say unique list, I get almost the same output, but the word awk only appeared once. Okay, well, bash still appeared down here, and it appeared here, and it appeared here. It didn't take those out because they weren't consecutive. But if I had all my bashes sitting next to each other, I could filter them all out. And one way to do that is to sort my list. So if I sorted, all my VIs are together, all my system Ds are together, and so on. And if I take this and I run it through unique, now I've got exactly 1 line for each unique command. And if I take that and I word count it, there's only 86 unique commands. So this is just an example of taking commands and putting them together, right? Which we do a lot in Unix. And this goes back to this idea of having a toolkit, right? With a few things you can do, sorting, uniquing, word counting, but you can put them together in a variety of ways and sort of tailor your task to whatever you're trying to do. So we'll play a lot more with pipes, probably next week or the week after. But that's a bit of a preview. So let's go back to this file. This is a big long file. Suppose I wanted to see what was in the beginning of this. So So there's a command called head, which shows you the first 10 lines of a file. And there's also a tail, which shows you the last 10 lines of a file. And we can put switches on this. We can say head -5, and it'll show us the first 5 lines. So if we have large files and we only care about the beginning or the end, head or tail are useful. And so if I want to know the first user alphabetically who's logged on to the system, I could take who, put that into sort, pipe it into head -1, and it's and a weird little command that's really useful, a weird little switch is tail -f. So I can tail -f a file and it will show me the end of the file, but it won't return at that point. It will sit here. And if somewhere down the road that file changes and gets more stuff in it, it'll suddenly appear on this window. And you can use this to monitor files. If you have a file, say a log file that's got things being written into it, every time that something appears at the bottom of that file, I'll start seeing it here. And that's surprisingly useful if you have like a long command that's sitting in the background and slowly adding things to a file. Instead of continually checking the file to see if there's anything new, you can do a tail -f and just leave it in the window and it'll just update automatically. And that's remarkably useful. All right, we've talked about alias. Oh, you Control C, get out of that. We've talked about alias, right? So I can change go to be the GCC command, and now when I say go, it'll try to call the compiler. Or I could make go something like git push origin master, and when I want to push my stuff over to GitLab, I just say go, or I say push, or I say backup, or whatever. And you can set up all kinds of aliases. All right, so got a few more Unix commands to talk about another day. And then I want to start digging into some of the more interesting things we can do in shell scripting. We'll talk about PA3 tomorrow, which will be a shell script assignment again. So we're going back to Bash programming for PA3. We'll talk about that. We'll maybe play around with some flowcharting for that. And we'll go from there. All right, so I'll see you tomorrow.